Problem number 22. A point mass m sits on a long block, also of mass m, which rests on the floor. The coefficient of static and kinetic friction between the mass and the block is mu, and the coefficient of static and kinetic friction between the block and the floor is mu over 3. And impulse given a horizontal momentum p to the point mass. After a long time, how far has the point mass moved relative to the block? Assume the mass does not fall off the block. Problem number 23. Assume that the drag force for a fish in water depends only on the typical length scale of the fish r, its velocity v, and the density of water ρ. A puffer fish is about 10 centimeters in length and swims at about 5 meters per second. How fast does a clownfish about 1 centimeter in length need to swim such that it experiences the same drag force as the puffer fish? Problem number 24. 3 boxes A, B, and C lie along a straight line on a horizontal frictionless surface, as shown. Box A is initially moving to the right with a speed v, while the other 2 boxes are initially at rest. If all collisions are elastic and the masses of the boxes can be chosen freely, which of the following is closest to the maximum possible final speed of box C? Problem number 25. If a certain radioactive decay process happens n times per hour on average, then in any given hour, one expects to observe n decays with an uncertainty of square root from n. Each hour can be assumed independent of the previous one, and n can be assumed constant over time. How many hours do you need to conduct the observation so that you can determine n within an uncertainty of 1%?